The first step in this problem is to balance the equation, and again I'm going to pick an element that only appears once. I'm going to start with the manganese. Manganese is balanced on both sides, so I'm happy with that. Oxygen is not, so I'm going to put a 2 in front of the water there. Now we have 4 hydrogens on the right. That's going to require 4 in front of the HBr on the left. Taking a quick look at this, it looks balanced right now. So for any limiting reactant problem, I'm going to anticipate what the question is asking me. How many grams of magnesium, manganese 2-bromide will be produced. So I'm going to use that as my target molecule to base my calculation on. So what I'm going to do is assume that all of the MnO2 reacted and see how many grams of MnBr2 could be produced. So this is just a stoichiometry calculation that I'm going to do right now. And what this is suggesting is that if all the MnO2 reacted, we could produce 1.724 grams of MnBr2. The HBr calculation is very similar, so I'm not going to do this, and it's in my answer key in the Dropbox. But if you had this many grams of HBr reacting, you could produce 0.6173 moles of MnBr2. I actually note that this should not be grams, but rather moles. And you don't need to go to grams because whatever produces the fewest amount of moles is also going to produce the fewest number of grams. At this point, this is the amount of MnBr2 that we can produce. We cannot produce this much MnBr2 simply because we don't have enough HBr. So this is the limiting reactant, and this must be the excess reagent. So that sort of answers the first part. What is the limiting reagent? The limiting reagent is HBr. How many grams of MnBr2 will be produced? Well, we can convert this molar amount to grams, and that's how we would solve that problem. And the answer I get here is 132.7 grams of MnBr2. Now remember that the limiting reactant is completely consumed, so there would be 0 grams of that left. However, the excess reagent will be left over, so let's see how we could do that. So what I'm going to do here is calculate the amount of MnO2 that is required to produce the amount of product. So I know that I'm producing 0.6173 moles of MnBr2, and I want to know how many grams of MnO2 are required to produce this amount. So I'm getting confused with all the Mn. So what the calculation should look like is the following. I know that there's 1 mole of MnO2 for every 1 mole of MnBr2. Again, remember this is the amount of MnBr2 that is produced, and I can convert to mass using the molar mass. And this gives you 53.71 grams of MnO2. So this is the amount that reacted. It is not the excess left over, and that's a common mistake that I see people making. They just put that as the answer. The excess left over is going to be the starting amount, which is 150.0 grams, minus the amount that reacted, which is 53.71 grams. Of course, significant figures, 1 decimal point place here, and we get 96.3. So this is the amount of MnO2 that is left over after the reaction because it is the excess reagent.